Hi, and welcome to this video. Today I'm going to talk about free body diagrams, net forces, and do some Newton's second law practice. So what is a free body diagram? You might be wondering, is it any of these kinds of free? Well, no. In physics, we're going to use the term free body for another reason. So let's get right to it. Free body diagrams are a way to determine and illustrate all applied forces on an object or body. The term free here really just means any sort of object which is free to move. We have a problem scenario on the right here where this blue man is pushing on a wooden block. The wooden block can be considered a free body because it's not bolted to the ground. It's free to move around. Since the guy is pushing on it, he can move the block because it's on a frictionless surface. Okay, so let's make some steps on how to make a free body diagram. So first we're going to decide about which object or body we care about. In this case, I was just talking about the wooden block. So that is in fact the object that we care about. And it is our free body because it can move. Second, we then need to draw a box on its own to represent our object. So here we have a square drawn here that represents our block. Here we have a rectangle drawn as a square, but this square could really represent anything. It could represent a car, it could represent a rocket ship, it could represent really anything that's free to move. Our third step here is we need to determine all the forces which are being applied to the body. So in this case, we have one force which is being applied by this blue man. He's pushing on the block to the right. We're assuming that there's no friction here because it states frictionless surface on the bottom. We then add all the applied forces into our free body diagram using arrows and labels. So here we have an arrow coming off the right side of the box pointing to the right because the man is pushing to the right. And we label it with an F. Okay, so let's get right into an example problem. So here we have the strongman truck pull. So here's the problem statement. In a strongman competition, a man pulls a 2,200 kilogram truck with a rope. The man pulls the rope with a force of 1,950 newtons. However, there's a 250 newton frictional force between the tires and the rope. Draw a complete free body diagram, which involves all forces, and then solve for the net force and acceleration of the truck. So here we have this guy who's pulling a truck with just a rope. All right, so let's take a look. So our free body diagram. Again, even though it's a truck in this case, we're still going to draw it with just a square. We're always going to use a square as our free body diagram centerpiece. So now we got to add in all of our forces. So the first force that you might think of is the obvious one, which is the force of the rope being pulled to the right. Since the man is pulling with a rope, and it's the rope that's really pulling directly on the truck, we're going to make a force tension because there's tension in the rope, which is causing the truck to move to the right. So our force tension here is 1950 based on the problem statement. Excellent. So now there also is a second force given in the problem, which opposes this force, which is due to friction. Here we have F with a subscript F, which is 250 newtons. Excellent. So now we have these two forces which are opposing each other. But are these the only forces that we have in the system? Well, no, because the truck doesn't fall towards the center of the earth. It isn't flying upwards up towards space. So there must be some balanced forces in the y direction as well. So let's take a look. The truck has mass, so it must have some weight because of the mass, right? So here we have a force due to its weight of 21,582 newtons. This force comes from using the mass times the acceleration due to gravity, which is 9.81 meters per second squared. If we have a force weight of 21,582, we must then also have an equal and opposite normal force of 21,582 newtons because the object or the truck here does not accelerate in the vertical direction either up or down. So we really don't care about either of those forces because they effectively cancel when we look at net forces. But in the horizontal direction, our forces are not equal and opposite, so we have to figure out what the net force will be. Again, the mass of the object is 2,200 kilograms. That helped us find the weight of the truck, and it'll also help us later on when we use Newton's second law. So let's start with the net force. Again, in the net force, we're going to add up the forces. Just like I stated before, the force normal and the force weight we don't really care about right now because those are equal and opposite in the vertical direction, so those cancel, so we're not worried about those. The ones that we do care about are friction and tension. When we add those together, we got to make sure that we note that 250 is negative because friction acts to the left in this case. So we have 1,950 minus 250, which gives us a net force of 1,700 newtons acting to the right on this truck. Okay, excellent. Now that we have the net force that's acting on this truck due to the man, we can now solve for the acceleration of the truck. So To solve for acceleration, we're first going to start with Newton's second law, which is the net force is equal to mass times acceleration. But in this case, we're solving for acceleration, so we're going to get a on its own. We divide both sides by m. The m's cancel on the right, and we're left with acceleration is equal to force net over mass. We then plug in the net force that we just solved for, along with the mass that was given in the problem, and we solve for acceleration, which is at a rate of 0.77 meters per second squared. That is our final answer. So in this problem, we have this strongman who is able to accelerate a truck to the right at a rate of 0.77 meters per second squared. So in this problem, we were able to take the problem statement, make a free body diagram using a square, represent all of our forces on there, break down what the net force was, and then finally solve for the acceleration using Newton's second law. So this concludes our video about free body diagrams, net forces, and Newton's second law.